Okay, hello everyone. In our last class, we have been discussed hygiene eyepiece. We discussed its construction, working. Then we discussed location of cardinal points by using system of matrix. In detail, we have been discussed. Okay. Then we discussed a question based upon the cardinal points. Step by step, we have been discussed. Okay. Then I given a assignment that you have to do by yourself. In this class, we are going to discuss comparison of Ramsden's eyepiece and hygiene eyepiece. Okay, so let us start here. This is the comparison. This is the construction of Ramsden eyepiece. This is the construction of hygiene eyepiece. Already we have been discussed in our previous classes. Here the comparison starts. First point, two plano-convex lenses made up of same material with their convex side facing each other for Ramsden eyepiece. So here field lens, eye lens are two plano-convex lenses made up of same material. Convex side means this side. Convex side means this side facing each other inwards. Okay, facing each other. For hygiene eyepiece, two plano-convex lenses made up of same material with their convex side, this is the convex side, facing towards objective lens. Facing towards objective lens. These things already we have been discussed in their corresponding videos itself. But these are comparisons. You just remember these points. See, if this question will be asked in your exam, it will ask for 3 to 4 marks. Okay. Here, ratio of a focal length of a field lens and eye lens is your 1:1. That means field lens focal length is your f and eye lens focal length also f. Okay. Here 3:1. The ratio of focal length of field lens and eye lens. That means if eye lens focal length is your f, then field lens focal length will be 3f. Okay. Distance between the field lens and eye lens for Ramsden case is your 2f by 3 here. 2f by 3 is the separation distance between the two lenses. In case of hygiene eyepiece, the separation is your 2f. Okay, 2f, and here f is the focal length of eye lens. This is most important point. You have to remember this point also need whenever you are going to solve a question based upon the Ramsden and hygiene eyepiece. That distance between the field lens or separation between the two lenses is your 2f by 3. Here 2f, and this f particularly is nothing but your focal length of eye lens. Fourth point, Ramsden eyepiece is a positive. This is also one important point. This Ramsden eyepiece is a positive eyepiece as the image formed by the objective lens which lies in front of the field lens. Here this image formed by the objective, this one I1, which is formed in front of the field lens. Only for that it is called as the positive eyepiece. But in case of hygiene eyepiece, it is called as the negative eyepiece, because image formed by the objective, this is your I1, in between the field lens and eye lens. Image formed by the objective lens which lie in between field lens and eye lens. In between field lens and eye lens. So only for that it is called as your negative eyepiece. Okay. Now we are going to move our next point. Here, fifth point. In this eyepiece, generally crosswire is used, but in this hygiene eyepiece, crosswire is not used. Okay. Sixth point. It does not satisfy the minimum spherical aberration condition. Here, minimum spherical aberration condition is your d equal to f1 minus f2. This is the separation between the two lenses. But here it satisfies the minimum spherical condition, that is your d equal to f1 minus f2. How? Here you can see. For this case, the separation between the two lenses is your 2f. Okay. If we are going to consider the focal length of the eye lens is your f, then field lens focal length will be how much? 3f, because it is 3:1. So if I am going to differentiate, this is your f1, this is your f2, that means 3f minus f is your 2f. Here it obey the spherical aberration condition, that is your d we found here 2f, that means separation between the two lenses is 2f, right? But if we are going to consider Ramsden eyepiece, here field lens and eye lens having same focal length because ratio is your 1:1. So if we are going to consider this condition, that is your f minus f equal to 0, that means separation should be 0, but here separation is how much? 2f by 3. So for spherical aberration, if we are going to consider, it does not obey, it does not satisfy, Ramsden eyepiece does not satisfy, but Huygens eyepiece satisfy. Only for that here I written, therefore generally it is used for monochromatic color or single wavelength, for single wavelength. Which one? Ramsden eyepiece. But as it is obey the spherical aberration condition, then it can be used for multicolor or white light. Okay, you just remember this is also one important point. Here the nodal points are coincided with the principal point, and for this case also nodal points are coincided with principal points. This eyepiece used in telescope, this eyepiece, Huygens eyepiece, used in microscope. Okay, here with these 8 points we have been compared between Ramsden and Huygens eyepiece. Okay, so if this question will be asked in your exam for 3 to 4 mark, then uh, these points at least you have to write here. This one, this first point, second point, and third point, fourth point, and this 8th point. These 5 points you have to write. May you are going to write or not these 3 points, but these 5 points are important. Okay, 1 2 3, these 4 and this one. It is used in telescope and it is used in microscope. And here, this is one of the most important short question. Ramsden eyepiece is a dash eyepiece, positive eyepiece, whereas Huygens eyepiece is a dash eyepiece, negative eyepiece. You have to write. Or sometimes true or false may be asked in your exam for 1 mark, that Ramsden eyepiece is negative eyepiece. Is it true or not? That type of 1 mark question you can get in your exam. Okay, so that's it for this lecture. In our next lecture, here you can see in your syllabus we completed these topics. Next class, this topic we are going to discuss. Idea of dispersion, angular dispersion, and dispersive power. Okay, so thank you so much for watching this video. Thank you.